Hello and welcome to Stories of Science. Here, we look back on humanity's long journey to understand the world. The questions, the failures, and the breakthroughs that slowly changed how we see the universe and ourselves. We tell science as stories. Everything we know about the moon is stranger than you think. It's late. People finish work, step outside, and glance up at the sky the same way they always do. The stars are still there. The city is still buzzing. Everything seems normal. And yet, something feels wrong. Then it hits you. The moon is gone. Not hidden by clouds. Not a lunar eclipse. Not a new moon. Gone. Completely gone. Imagine that tonight, the moon simply vanished from the universe. What would happen? The first signs would appear in the oceans. The moon is the main force behind Earth's tides. Without it, the familiar rise and fall of the seas would change dramatically. Coastlines around the world would lose the celestial conductor that has directed them for billions of years. But the oceans would only be the beginning. Earth itself would start feeling the loss. Most people don't realize that the moon acts like a giant stabilizer. It helps keep Earth's rotational axis relatively steady. Without that influence, our planet could experience far more dramatic shifts in climate over millions of years. And then comes the heartbreak for skywatchers. Total solar eclipses would disappear forever. That breathtaking moment when the moon perfectly covers the sun is possible only because of an extraordinary cosmic coincidence. Remove the moon, and the show ends. Many animals would also lose a critical guide. Sea turtles, migrating birds, insects, and countless nocturnal species use moonlight to navigate. Behaviors refined over millions of years could suddenly be thrown into chaos. Even human civilization might have developed differently. The moon has been our clock, our compass, and our storyteller. It inspired calendars, guided sailors across oceans, appeared in myths, poems, religions, and legends on every continent. You could argue that while humanity was looking at the moon was quietly shaping humanity. And yet, here's the strange part. Despite seeing it almost every night, we still don't fully understand it. The moon sits only about 384,000 kilometers away. It's the only world beyond Earth that humans have ever walked on. Yet scientists are still debating how it formed, what lies inside it, and what secrets may be hidden on the far side. The most surprising discovery of all? Evidence increasingly suggests that our ancient companion was born from one of the most violent events in Earth's history. In other words, the moon isn't just decoration hanging in the night sky. It's more like the scar left behind by a colossal accident from Earth's childhood. And that story begins around 4.5 billion years ago. If the solar system were a neighborhood, the moon would be Earth's closest friend next door. On average, it's about 384,400 kilometers away and measures roughly 3,474 kilometers across, about 1/4 the diameter of Earth. At first glance, that doesn't sound particularly impressive. But astronomers noticed something unusual long ago. Compared with its parent planet, the moon is surprisingly large. Jupiter's moon Ganymede is much bigger. Saturn's moon Titan is bigger too. Both even exceed Mercury in size. But Jupiter and Saturn are giants. Earth is not. Relative to Earth, the moon is unusually massive. Its diameter is about 27% of Earth's, and its mass is roughly 1/80th as much. Some researchers have even described the Earth-Moon system as a kind of unfinished double-planet system. In fact, the moon doesn't simply orbit Earth. Both bodies orbit a shared center of mass. Earth itself performs a subtle wobble as the moon tugs on it. It's a reminder that gravity is always a two-way street. And the moon's influence goes far beyond gravity. It shapes tides, helps stabilize Earth's orientation, and has played a role in human history for thousands of years. Ancient civilizations tracked its phases. Sailors used it to navigate. Farmers planned around it. The moon became a natural clock hanging in the night sky. But as scientists studied it more carefully, a puzzle emerged. The moon shouldn't look the way it does. At least, not according to the simplest models. So where did it come from? For most of human history, the answer came from mythology. Different cultures imagined different stories. Some saw gods. Some saw heroes. Others saw rabbits, spirits, or celestial kingdoms. Then science stepped in. Researchers proposed several explanations. Maybe the moon formed elsewhere and was captured by Earth's gravity. Maybe Earth and the moon formed together from the same cloud of material. Maybe a rapidly spinning young Earth flung part of itself into space. Each idea explained part of the mystery. None explained everything. Then, during the 1970s, a new theory gained momentum, and it sounded like something straight out of a disaster movie. Around 4.5 billion years ago, the early solar system was a chaotic place. Worlds were still forming. Objects were colliding constantly. You could call it the biggest demolition derby in cosmic history. At some point, a young Earth was struck by a planetary body about the size of Mars. Scientists call it Theia. The impact was unimaginably violent. Rock was blasted into space. A vast ring of molten debris formed around Earth. Over time, those glowing fragments collided, merged, and gradually built a new world. The Moon. But the newborn Moon looked nothing like the one we see today. Its surface was likely covered by a global ocean of magma, and it orbited much closer to Earth. If someone could have stood on our planet back then, the Moon might have appeared several times larger in the sky than it does now. It wouldn't have looked like a moon. It would have looked like a second world looming overhead. Still, many questions remain. What happened to Theia? Why are Earth and Moon rocks so remarkably similar? How quickly did the Moon form after the collision? Scientists have made enormous progress, but the full picture remains incomplete. As the saying goes, the more you know, the more you realize you don't know. And strangely enough, the Moon's birth may not be the most fascinating part of its story. What happened after it formed may be even more extraordinary. One of the biggest misconceptions people grow up with is that the Moon doesn't rotate. It's easy to see why. Every time you look up, the same familiar face is staring back at you. It's like that neighbor who's used the same profile picture for billions of years. But appearances can be deceiving. The Moon is spinning. In fact, it rotates once every 27.3 days and just happens to orbit Earth in almost exactly the same amount of time. The result? We always see nearly the same side. Astronomers call this tidal locking. Billions of years ago, things were very different. The young Moon spun much faster, but Earth's gravity constantly pulled on it, creating internal friction that gradually slowed it down. Think of it as nature applying the brakes, little by little, for millions of centuries. Eventually, the Moon settled into the cosmic routine we see today. But here's a twist. We don't actually see only half of the Moon. Because its orbit is slightly tilted and not perfectly circular, the Moon performs a subtle wobble known as libration. Sometimes it seems to nod. Sometimes it appears to shake its head. Sometimes it drifts slightly from side to side. Over time, these tiny motions allow us to glimpse about 59% of the lunar surface. The remaining 41% remained completely unknown for most of human history. Then came October 7, 1959. The Soviet spacecraft Luna 3 flew around the far side of the Moon and captured the first photographs ever taken of that hidden hemisphere. By modern standards, the images looked blurry and primitive. Back then, they were revolutionary, because the far side looked nothing like the side facing Earth. But before we explore that mystery, let's take a closer look at the Moon's familiar face. When you look at a full moon, you can easily spot dark patches scattered across its surface. Ancient astronomers believed these regions were seas and gave them names like the Sea of Tranquility and the Sea of Rains. Turns out, not a drop of water exists there. These seas are actually vast plains of ancient lava. Billions of years ago, massive impacts cracked the lunar crust. Molten rock flooded the surface, cooled, and left behind enormous dark regions that still stand out today. The brighter areas tell a different story. These highlands are among the oldest landscapes in the solar system. Some rocks brought back by Apollo astronauts are over 4.4 billion years old, making them nearly as ancient as the Moon itself. If the highlands preserve the Moon's childhood, the craters preserve its entire life story. Unlike Earth, the Moon has almost no atmosphere, no weather, no wind, no oceans, no protective shield. For over 4 billion years, asteroids and meteoroids have slammed directly into its surface. The result is the battered world we see today. One of the most famous scars is Tycho crater. Roughly 85 kilometers across, it formed about 108 million years ago, a youngster by lunar standards. Its bright streaks stretch more than 1,500 kilometers across the surface and are easily visible during a full moon. Copernicus crater is even larger. Clavius is larger still, a giant impact basin filled with smaller craters nested inside one another like Russian dolls. But the moon isn't just a collection of craters. It has mountains too. The lunar Apennine Mountains stretch for hundreds of kilometers, with peaks rising nearly 5,000 meters high. Some would rank among Earth's most impressive mountain ranges. There are valleys, fault lines, and giant fractures as well, ancient scars left by a world that was once far more active than it appears today. And then there's the environment. This is where things get truly extreme. Without an atmosphere to trap heat, temperatures can soar to 127 degrees Celsius during the lunar day. At night, they can plunge to minus 173 degrees. That's not a weather forecast. That's the same location, just 2 weeks apart, because a single lunar day lasts about 29.5 Earth days. Imagine working a job where daylight lasts 2 straight weeks before the sun finally sets. Yet despite all the craters, mountains, lava plains, and dramatic temperature swings, the moon's biggest secrets aren't on the surface at all. They're buried deep inside. From Earth, all we can see is the outer shell. The real mystery lies beneath it. What exactly is inside the moon? Unfortunately, scientists can't slice it open like a watermelon and take a look. For most of history, the lunar interior was little more than an educated guess. That changed during the Apollo era. When astronauts landed on the moon between 1969 and 1972, they didn't just collect rocks. They left behind scientific instruments. Among the most important were seismometers, moonquake detectors. At first, that sounds strange. Why put earthquake sensors on a world without moving tectonic plates? Because scientists wanted to perform a giant planetary CT scan. Seismic waves travel differently through different materials. By measuring those vibrations, researchers could begin mapping the moon's hidden layers. From 1969 until 1977, the instruments recorded thousands of seismic events. For the first time, the moon started revealing its secrets. The first surprise was the crust. Scientists discovered that the moon's near side and far side are dramatically different. The crust facing Earth averages roughly 30 to 40 kilometers thick. On the far side, many regions exceed 60 kilometers, and some approach 80. It's as if one side of the moon is wearing a winter coat while the other is dressed for summer. That imbalance puzzled researchers for decades. Then NASA's Grail mission, launched in 2011, mapped the moon's gravity in extraordinary detail and confirmed that the difference is real. The uneven crust may explain why the two sides of the moon look so different. Below the crust lies the mantle. This enormous layer makes up most of the moon's volume. Apollo samples revealed minerals similar to those found in Earth's upper mantle, suggesting the two worlds share a surprisingly connected history. Scientists believe that shortly after its formation, the moon was covered by a global ocean of magma. As it cooled, lighter minerals floated upward and formed the crust. Heavier materials sank deeper and became the mantle. The lava that later created the dark lunar Maria likely originated from these deep interior layers. For years, researchers assumed the moon became geologically dead long ago. Case closed. Or so they thought. New evidence suggests the moon stayed active much longer than expected. Data from China's Chang'e missions indicate that volcanic activity may have continued until around 2 billion years ago. Studies of samples returned by Chang'e 5 even suggest eruptions could have occurred as recently as 1.2 billion years ago. For a world born 4.5 billion years ago, that's staying up surprisingly late at the party. Deeper still lies the moon's most mysterious region, its core. For decades, scientists debated whether the moon even had a true metallic core. Today, the answer appears to be yes. The moon contains an iron-rich core. It's just tiny compared to Earth's. Earth's core stretches roughly 3,500 kilometers from the center. The moon's core is only about 330 to 400 kilometers in radius. If the moon were an apple, the core would be a relatively small seed at its center. And it gets even more interesting. Modern studies suggest that part of the lunar core may still be liquid. In 2011, researchers reanalyzing Apollo seismic data found evidence for a solid inner core surrounded by a liquid outer layer similar to Earth's structure, but on a much smaller scale. That discovery hinted that the moon was once far more dynamic than anyone expected. Which brings us to moonquakes. Most people imagine the moon as silent and motionless. It isn't. The moon shakes regularly. Some quakes occur deep underground and are triggered by Earth's gravitational pull. They happen so predictably that they resemble a monthly alarm clock. Others occur much closer to the surface. They're less common but considerably stronger. One recorded during the Apollo era reached a magnitude close to 5 and continued for an astonishing length of time. Then there are impact quakes. Every meteoroid strike sends vibrations racing through the lunar interior like a hammer striking a giant bell. And that's the key difference. The moon is extremely dry. Without groundwater to absorb energy, seismic waves can continue bouncing around for a very long time. An earthquake on Earth may fade within minutes. A moonquake can keep ringing for over an hour. Apollo scientists once compared the moon to a giant bronze bell. Hit it once, and it just keeps ringing. Yet perhaps the strangest discovery wasn't the moonquakes. It was magnetism. Today, the moon has almost no global magnetic field. It offers little protection from the solar wind. Yet rocks returned by Apollo missions tell a different story. Billions of years ago, the moon appears to have possessed a surprisingly powerful magnetic field. Some evidence suggests that between about 4.2 and 3.5 billion years ago, its magnetic strength may have rivaled Earth's. That shouldn't have happened. Small worlds are supposed to cool quickly. So where did the energy come from? Some scientists think the young moon spun much faster, driving a more active molten core. Others argue that Earth's gravitational pull supplied additional energy. Whatever the mechanism, the lunar dynamo eventually shut down around 3 billion years ago. The magnetic field faded. The mystery remained. And as researchers pieced together clues from crust thickness, mantle evolution, ancient magnetism, and seismic data, a bold idea began to emerge. Maybe the reason the moon's near side and far side look so dramatically different isn't written on the surface at all. Maybe the answer has been hiding deep inside the moon this entire time. If the moon's near side is the familiar face humanity has known for thousands of years, the far side is the neighbor who never opens the door. For most of human history, nobody had ever seen it. The reason is surprisingly simple. The moon is tidally locked to Earth. It spins on its axis at almost exactly the same rate that it orbits our planet. As a result, the same side always faces us. Ancient astronomers, kings, philosophers, even great minds like Galileo and Newton, all of them looked at the same lunar face. Then came 1959. On October 7, the Soviet spacecraft Luna 3 flew behind the moon and captured the first images of the mysterious far side. By today's standards, the pictures looked blurry and grainy. Back then, they were revolutionary. And what they revealed shocked scientists. The far side looked nothing like the side facing Earth. The familiar side is covered with vast dark plains known as Maria, formed by ancient volcanic lava. The far side, however, is rough, mountainous, and packed with craters. It looked less like a welcoming landscape and more like nature had switched the moon into hard mode. As the saying goes, don't judge a book by its cover. The moon had been showing us only half the story. Over the following decades, scientists pieced together an explanation. The crust on the far side is significantly thicker than the crust on the near side. Billions of years ago, molten rock rising from the moon's interior had a much harder time reaching the surface there. Fewer eruptions meant fewer lava plains. The result is the dramatic contrast we see today. But the far side hides something even more spectacular. Near the lunar South Pole lies the enormous South Pole Aitken Basin. This colossal impact structure stretches roughly 2,500 kilometers across and plunges more than 8 kilometers deep. It is one of the oldest known scars in the solar system, likely formed over 4.2 billion years ago. Scientists suspect the asteroid responsible may have been more than 150 kilometers wide. The impact was so violent that, had it happened on modern Earth, civilization would have had a very bad day, an extraordinarily bad one. Yet the basin holds more than ancient damage. Data from NASA's Grail mission revealed strange gravitational anomalies beneath parts of the far side. Some regions appear denser than expected. Other missions detected unusual concentrations of heat-producing radioactive elements such as thorium and potassium. These discoveries hint that the Moon's interior may be far more complicated than anyone once imagined. And naturally, curiosity got the better of us. Humanity wanted to visit. On December 8, 2018, China launched the Chang'e 4 mission. Less than a month later, on January 3, 2019, it successfully landed inside von Karman crater on the Moon's far side. It was a historic first. Because the Moon blocks direct radio communication, engineers had to place a relay satellite called Queqiao in space beforehand. Without it, the lander would have been effectively cut off from Earth. Soon afterward, the Yuta 2 rover began exploring terrain no rover had ever explored before. Year after year, it sent back data about ancient impacts, deep lunar materials, and the geology of the far side. But while scientists were focused on mysterious craters and hidden structures, another discovery quietly stole the spotlight. The Moon might not be as dry as everyone thought. For decades, textbooks described it as a barren world without water. Apollo samples seemed to support that idea. Then, in 2008, India's Chandrayaan-1 mission detected signs of hydroxyl molecules and water-related compounds on the lunar surface. Astronomers took notice. Maybe the Moon wasn't completely bone dry after all. The following year, NASA's Lunar mission deliberately crashed a rocket stage into a permanently shadowed crater near the lunar south pole. When the impact plume was analyzed, scientists found clear evidence of water ice. Suddenly, the Moon looked very different. Its greatest treasure wasn't hidden in giant craters. It was hidden in the dark. Near the poles, especially around the South Pole, some crater floors never receive sunlight. The Moon's axis is tilted by only about 1.5 degrees, leaving these regions trapped in eternal shadow. Temperatures there can plunge below -200 degrees Celsius. Some spots are colder than parts of Pluto. They are essentially giant cosmic freezers. Scientists estimate these frozen regions may contain hundreds of millions, perhaps even billions, of tons of water ice. And the water likely came from several sources. Some arrived aboard ancient comets. Some came from water-rich asteroids. Some may have formed when hydrogen from the solar wind interacted with oxygen in lunar rocks over billions of years. Slow process. Huge timescale. Big results. After all, little strokes fell great oaks. And for future explorers, water may be worth far more than gold. It can be drunk. It can be split into oxygen for breathing. It can also be separated into hydrogen and oxygen to produce rocket fuel. In other words, future lunar settlers may not need to ship every critical resource from Earth. That realization has changed everything. Today, when space agencies map out the next chapter of lunar exploration, their attention keeps returning to the same destination, the Moon's south pole. But finding water and building a permanent home are two very different challenges. Because despite its beautiful appearance, the Moon is anything but welcoming. The first major problem is lunar dust. The name sounds harmless. It isn't. Lunar dust is more like countless microscopic shards of glass. Without wind, rain, or weather to smooth the particles down, the sharp edges remain intact. Apollo astronauts quickly discovered that the dust stuck to everything: spacesuits, equipment, tools, and even the inside of their spacecraft. Apollo 17 astronaut Harrison Schmitt developed allergy-like symptoms after exposure. The crew jokingly called it lunar hay fever. Future Moon residents may spend less time sweeping floors and more time fighting dust invasions. The second challenge is radiation. Earth protects us with both a magnetic field and an atmosphere. The Moon has neither. Solar particles and cosmic rays strike the surface directly. Radiation exposure on the Moon is estimated to be more than twice that experienced aboard the International Space Station. Sunbathing on the Moon would be a very different experience from a beach vacation. Then there are micrometeorites. Earth gets hit by them constantly, but most burn up in the atmosphere before reaching the ground. The moon has no such shield. Tiny particles can slam into the surface at tens of kilometers per second, turning invisible grains into natural bullets. Spacesuits, solar panels, and habitats all have to withstand this endless bombardment. And that's before we mention the temperatures. Daytime can reach 127 degrees Celsius. Nighttime can plunge to minus 173. Metal expands, contracts, and expands again. Machines don't particularly enjoy that routine. Even the lunar day is extreme. One full day-night cycle lasts about 29.5 Earth days. Imagine 2 weeks of daylight followed by 2 weeks of darkness. That's not a work schedule most people would volunteer for. Yet none of these obstacles have stopped humanity, because the dream of returning to the moon never really disappeared. In fact, the story of the first moon landing remains one of the greatest adventures of the 20th century. It began during the Cold War. In 1957, the Soviet Union launched Sputnik 1, the world's first artificial satellite. The United States was stunned. NASA was created the following year, and the space race was underway. Then, on April 12, 1961, Yuri Gagarin became the first human in space. America found itself behind again. Just weeks later, President John F. Kennedy stood before Congress and proposed what sounded almost impossible: land a person on the moon and return them safely to Earth before the decade was over. Many experts thought it couldn't be done. America did it anyway. The Apollo program became one of the largest scientific and engineering efforts in human history. Hundreds of thousands of people contributed. Universities, laboratories, manufacturers, and engineers all joined the effort. Finally, on July 16, 1969, Apollo 11 lifted off from Florida atop the mighty Saturn V rocket. 4 days later, the lunar module Eagle began its descent. As Neil Armstrong approached the surface, he noticed dangerous boulders near the landing area. Fuel reserves were dropping fast. Less than 30 seconds remained. He took manual control. Moments later, history changed. The Eagle has landed. A few hours afterward, Armstrong stepped onto the lunar surface and became the first human to walk on another world. Buzz Aldrin soon joined him. Together they conducted experiments, collected samples, and left footprints that remain there today. Between 1969 and 1972, 12 astronauts walked on the moon. Later Apollo missions even deployed lunar rovers, allowing astronauts to travel kilometers across the surface instead of hopping around like cautious kangaroos in spacesuits. They returned with hundreds of kilograms of lunar rocks. Those samples helped reveal the moon's age, its history, and its likely origin in a giant collision billions of years ago. But as the old saying goes, all good things must come to an end. On December 14, 1972, Apollo 17 astronaut Eugene Cernan left the lunar surface. To this day, he remains the last person to leave footprints on the moon. The reasons were practical. The missions were expensive. The risks were enormous. And the political motivations driving the space race had begun to fade. Humanity left the moon. And for more than 50 years, nobody returned. But the moon's story was far from over. The more we explored the moon, the more surprises we found. For example, what does the moon smell like? Believe it or not, Apollo astronauts actually had an answer. No, they didn't take off their helmets and sniff the lunar surface. That would have made for a very short mission. What happened was that lunar dust clung to their suits and came back inside the spacecraft. Once there, astronauts noticed a strange odor. Apollo 17 astronaut Harrison Schmitt compared it to freshly fired gunpowder. Apollo 16 astronaut John Young said it reminded him of burnt matches. Then there are the famous footprints. On Earth, wind, rain, and flowing water erase tracks surprisingly fast. The moon has none of those things. No weather. No atmosphere. No erosion. Unless a meteorite strikes nearby, the footprints left by Apollo astronauts could remain visible for millions of years. And if you ever stood on the moon and looked up during the daytime, you'd notice something odd. The sky would still be black. Not dark blue. Not light blue. Black. Without an atmosphere to scatter sunlight, the moon never gets the colorful skies we enjoy on Earth. Instead, Earth itself would dominate the view, a glowing blue and white world appearing roughly 4 times larger than the moon looks from Earth. Jumping there would be an experience of its own. The moon's gravity is only about 1/6 of Earth's. A small hop could send you floating much higher than expected. Apollo footage often looks as if astronauts are moving in slow motion, like people bouncing across a giant trampoline. Even sunrise behaves differently. Because the moon rotates so slowly, the sun takes hours to climb above the horizon. If an Earth sunrise is a short video clip, a lunar sunrise is a full-length documentary. But while all this is happening, another story is unfolding quietly. The moon is slowly leaving us. Since Apollo 11, scientists have used laser reflectors placed on the lunar surface to measure the Earth-Moon distance with incredible precision. The result? The moon is drifting away at about 3.8 centimeters every year. That's roughly the width of a finger. It sounds insignificant, but over billions of years it adds up. Around 4 billion years ago, the moon may have been 10 times closer than it is today. It would have appeared enormous in the sky, and its tidal pull on Earth would have been dramatically stronger. As the moon moves outward, it also steals a tiny bit of Earth's rotational energy. Long ago, a day on Earth may have lasted only 6 to 10 hours. Today it lasts 24. And the clock is still slowing down. This gradual separation has another consequence. One day, total solar eclipses will disappear. Right now, we are living during an extraordinary cosmic coincidence. The sun is about 400 times wider than the moon, but it also happens to be about 400 times farther away. That makes both objects appear nearly the same size in our sky. Millions of years from now, the moon will appear too small to completely cover the sun. Future generations may know total eclipses only from photographs and history books. Of course, no discussion about the moon is complete without mentioning one of the most famous debates in modern history: the moon landing conspiracy theories. Ever since Apollo 11 landed in 1969, some people have claimed the mission was filmed on a movie set. One popular question is, why does the American flag appear to wave? The answer is surprisingly simple. The flag contained a horizontal support rod. When astronauts planted it, the motion caused the fabric to move. Because there is virtually no air resistance on the moon, the movement lasted longer than it would on Earth. Another common question is why stars aren't visible in the photographs. Again, the explanation comes down to photography. The lunar surface under direct sunlight is extremely bright. Camera exposures were set for the illuminated landscape, making faint stars invisible just as you rarely capture stars in daytime photos on Earth. Claims about strange shadow angles are usually explained by uneven terrain, perspective effects, and wide-angle camera lenses. And perhaps the strongest evidence is still sitting on the moon today. The laser reflectors left by Apollo astronauts continue to function. Observatories around the world still use them to measure the Earth-Moon distance. Since 2009, NASA's Lunar Reconnaissance Orbiter has also photographed Apollo landing sites, revealing spacecraft hardware, equipment, and even the paths astronauts walked across the surface. As more evidence accumulated, the case for the landings became stronger and stronger. But the real story isn't whether humans went to the moon. It's that we're preparing to go back. In November 2022, NASA successfully completed the Artemis I mission, the first major step toward returning astronauts to lunar orbit and eventually the surface. The goal is not simply to repeat Apollo. The goal is to stay. Plans for future missions include longer visits, permanent infrastructure, and the first woman to walk on the moon. At the same time, China's lunar exploration program continues to expand. From Chang'e 1 to Chang'e 6, each mission has revealed new pieces of the moon's story. And they're not alone. Around the world, space agencies are studying concepts for long-term lunar bases. Scientists are also interested in a resource called helium-3. It is extremely rare on Earth but may exist in larger quantities within lunar soil. Practical fusion power remains a challenge for the future, but helium-3 continues to attract attention as a possible energy source. Even more important, the moon could become humanity's gateway to deep space. Launching spacecraft from the moon requires far less energy than launching from Earth. Future missions to Mars and beyond may one day depart from lunar outposts rather than our home planet. And that brings us back to the beginning. About 4.5 billion years ago, the Moon was born from a catastrophic collision. It witnessed the formation of Earth. It watched dinosaurs rise and fall. It watched humanity emerge, build civilizations, and eventually learn to fly. For thousands of years, people could only place the Moon in myths and legends. A few decades ago, we finally walked across its surface. And perhaps someday, someone standing inside a lunar settlement will look through a window at the blue Earth hanging in the darkness. From that distance, our world may seem every bit as mysterious and beautiful as the Moon appears to us tonight. As the old saying goes, the journey of 1,000 miles begins with a single step. For humanity, that first step happened on the Moon. The next chapter may begin there as well. The people who changed the world. Usually just think one step deeper. If this story made you see things differently, hit like, subscribe, and save it. See you in the next story.